Hello and welcome back. Remember, I told you that I'm going to bring this in part two, right? So, this is it, the predicted chemistry practical WAEC 2026. So, in the previous video, please, if you have not seen the video, go and check it out. In the previous video, the volume of the acid, which I told you in standard can be gotten, VA will be about 12.10 to 12.50 centimeters cube, right? Now, the volume of the base is 25 centimeters cube, and the molar concentration of the acid gotten in that calculation was 0.103 mole per dm cube. Then the mole ratio 1:2, acid 1, base 2. Then the volume of the acid that we calculated there was 12.14. Now, this will give the examiner the standard value to use in your own calculation. So in your own calculation, when you do the titration, if your value does not fall very close to this or exactly this, then you are seriously in a very big trouble. But then you get a good mark when it falls around this value or exactly this value, but you have marks considered when you fall within this range. So don't forget. Okay, in case you are seeing a value within this range, just know that you are still safe. But if you have a value absolutely as this, know that you are perfect, right? So now let's look at what we have. Here we have the mass, the molar mass of the sodium hydroxide to be 40 grams per mole. Now, the first thing they ask us to do from this table is to calculate the concentration of what? Bn. Now, this N stands for your serial number. So let's say your serial number is 2, for instance. So your own will be B2. I think why I brought this to differentiate candidates from another, right? So you use your serial number here as a B, as the N value. Okay, so the first thing to do is to find the average volume of the acid that is used in this calculation. Remember, this is rough work, so it's not added, right? So the average volume of the acid, which is VA, will be gotten as this plus this. But how do we even get this value? The final reading minus initial reading will give you the volume of the acid used, right? So this minus this will give you this, and this minus this will give you this. Okay, so the average value, you just use this 12.13 plus 12.15. Then you divide it by what? 2. Where's our calculator? This calculator will never stay in one place. Okay, so we have 12.13 plus 12.15. Okay, so we are going to have, okay, let's divide it by 2 so that we have the final value. So we have 12.14 centimeters cube. Absolutely. So when you see this value corresponding with the value that you got from the calculation given from the sample paper, just know that you are good to go. So if you're a teacher, know that this value has helped you to understand that, okay, your students are good to go. But if they have a value within this range, 12.10 and 12.50, they are also very good to go. All right. Now, we have gotten the average volume of the acid used, 12.14 centimeters cube. So now let's calculate the concentration of the base in mole per dm cube. So I'm going to erase this so that I have space to do other things. Now remember, the volume we got is still the same, so we're going to be working with that. Now to get this, use this our interesting formula that say MAVA all over MB VB is equals to NA all over what? NB. Now remember, what we don't have here is VA. We don't have it. So we are going to calculate it. Okay, we have gotten VA already from this. What we don't have here is NB, because they say we should calculate the concentration of the base. So this is what we are looking for here. All right, so let's make this the subject of the formula. So MB will be equals to MAVA NB all over NAVB. So let's substitute values now. MA from our previous calculation was this 0.103. VA, we just calculated it 12.14. Then times NB is 2. all divided by Na, 1, Vd, volume of the pipette used, 25 centimeters, or volume of the base, right? So let's multiply this and divide it by 25, because 1 times 25 is 25. So 0.103 times 12.14 times 2, that will give you this value, 2.50084 divided by 25. So let's divide it by 25. So we have 0.1000. The zeros are so many, so we have mole per dm³. So the volume, the not volume, the mole concentration of the base is 0.100. So if you remember in our previous calculation, we also got this value, 0.100. So everything is corresponding. That means from the other side, you can walk down to this side, while from this side, you can also walk down that side. Okay, so let's see. The next thing they ask us to calculate is the concentration of Bn in grams per dm³. So let's see. Remember, in the calculation, the concentration of the base in gram per dm³ was 4.0, given by WAEC. So let's see if our calculation will give us 4.0. The moment we have 4.0, we know that we are absolutely correct. So this is how you see that in your volumetric analysis, people are having the full marks. These are all the checks and balances, right? Okay, so let me take this off. And then let's calculate the concentration in grams per dm³. Okay, so to calculate the concentration in grams per dm³, we will do like this: concentration